Nature and Nature Genetics bring together reports from 3 teams using new techniques for studying whole genomes of thousands of individuals to discover where addiction to nicotine and the link between smoking and cancer may lie. The teams who found the genetic markers were based in the USA, Europe, and Iceland.
The fascinating thing here is that the 3 papers, the 2 in Nature, 1 in Nature Genetics, have all found robust associations of the same chromosomal loci or area of the chromosome with lung cancer, but they've reached rather different conclusions on whether or not that is mediated through a propensity to smoke more cigarettes or be addicted to nicotine. So 2 of the papers suggest that the association is really with lung cancer, not with smoking. The other paper suggests that the association is really with smoking, and that's the reason that lung cancer risk is increased.
In Iceland, Kari Stephenson found a correlation between a particular gene locus and the tendency to become addicted to nicotine.
The dependence on nicotine, or the use of nicotine through smoking, is one of the big health hazards in our society. You inherit the tendency to become addicted to nicotine. You inherit the tendency to seek the environment, which is a tobacco smoke, that clearly contributes to the development of lung cancer.
In Iceland, thousands of people have had their whole genetic code analysed. This has recently produced new and exciting data about human disease.
When you have a large group of people in a small nation like the Icelandic nation, having the genealogy gives us an opportunity to impute the genome of about 3 times more people than we have actually put work into studying. And then we have the genealogy, and actually the genealogy of the entire nation going 1,000 years back in time.
Using samples from different populations, the other 2 groups identified a different reason for the correlation with disease, but all 3 groups found the same marker.
The excitement is through genome-wide association studies, we're able to locate a place in the genome that now serves as the beginning of a very exciting set of discovery and investigative activities that will hopefully give us that opportunity to give plausibility and biological understanding to why that part of the genome is so important for risk for developing smoking problems or lung cancer. If we look here, we see all of the different chromosomes are represented by different colors with their markers here. And you can see in chromosome 15 that these signals that are above the blue line that are suggesting that they're very strong statistical signals. You say, what part of the genome does this look in? We pointed on chromosome 15, and we say that part of the genome has a set of very interesting genes. There's an awful lot of similarity, particularly in the region where there's signal seen in some of these studies. We really have to look specifically at what's going on genetically. So now, this is the excitement. We see, aha, this particular acetylcholine receptor 5 alpha. Wow, that's a great gene. People have been interested in that for nicotine addiction for quite some time, and there's been some very exciting reports. All we know right now is that smoking and lung cancer are showing up in this particular region here. And since we know smoking and lung cancer are so closely related to each other, and in the studies that are reported, almost all the lung cancer patients had been smokers, we can't ferret that out yet.
Thousands of people studied, and in each individual millions of gene fragments. The new techniques help find locations in the genome which are very important to us all.
So this is what we like originally, but
We inherit from our father and our mother 1 copy of each particular gene variant. Each of these gene variants basically breaks down into 3 clusters when we actually do the analysis.
There's always a contribution both by the environment and by the genetics to the risk of that particular phenotype of that particular disease. My late father was an avid smoker, right? He smoked pipe as a young man, and when the big propaganda against cigarette smoking began, he said, I'm not going to let these people tell me how to behave, and he threw away the pipe and started to smoke cigarettes. And he died from lung cancer at the age of 67, unfortunately. I tried to smoke as a teenager. I failed completely. I'm one of these miserable failures as a smoker. And I just became nauseated and threw up. But then I have a daughter who is an avid smoker. And she smokes, even holds the cigarettes a little bit like her late grandfather.
So could these findings lead to tests which could help us decide what our risks are and how to behave as individuals? Carrie Stephenson's lab offers similar tests already.
I'm very optimistic that in due course we will be able to use samples and use this genetic information to be part of a paradigm for assessing personal and public health risk. This will occur, I think, over the coming years, but it's certainly not quite ready yet.
A lot of people ask whether they should go and get tested for these and other variants, and I think right now we're not ready to recommend testing for such a large number of gene variants across so many conditions. Where the data is still in evolution, we're going to find out more. The biggest problem is this is a deluge of information, and we've got no experience in communicating that information to individuals. If people wish to go and get tested, there are some companies setting up to do it, and that's people's own choice. But I don't think we're ready to recommend that as a clinical activity at this point.
What is important to keep in mind here is that it should be the decision of the individual whether or not they want to learn about their risk, and people should at least be given an opportunity of learning their risk and then deciding on their own whether or not it is enough for them to change their behavior. And I resent the patronizing view that people are not ready to learn about their risks. A very substantial part of who we are is the risk that we have of the common diseases that kill most people. So I think that we are always ready to learn more about ourselves.
Early days or not, David Hunter thinks all three papers signal important ways forward.
It's a wonderful time because we really finally can access the iceberg underneath the tip that we knew was there when we talk about inherited predisposition to disease.
The discovery element is really the key part of genome-wide associations at this point. And developing druggable targets based on what we see in these regions is really another one of the next generation sets of studies that have to go forward.
Smoking has so many different ill effects that it's very, very unlikely that there'll be anybody to whom we could responsibly say, you know, it's safe to smoke. So the population-wide advice is likely to remain unchallenged. Whatever way this comes out, smoking is still a very bad thing to be doing.